All right, today we are continuing looking at the law of sines, but today we're going to look at the ambiguous case. Day one we looked at when we had two angles and a side. You can use the law of sines there because you can always find the third angle using the triangle sum theorem. And we talked about a couple cases that had SSA, but we tailored them to the case where there was just one triangle. You have to exercise caution when you use law of sines in a case where you have two sides and a non-included angle. Depending on the relationships between two sides, there could be no triangle, one triangle, or two triangles that are possible. The textbook has this diagram here for you. Basically, if angle A is obtuse and A is less than B, that means that there's no triangle possible. If A is obtuse and it turns out that A is greater than B, then there's one triangle that's possible. So when it's obtuse, it's kind of easy. When it's acute, there are a couple different things that could happen. When H, which is the height of the triangle, meaning B times the sine of A, when that's greater than A, there's no triangle. When H is equal to A, there's one triangle. When A is bigger than B, there's one triangle. But if H is less than A, which is less than B, there are two triangles. Now, this is just kind of a lot of work. So I'm going to kind of have you ignore that idea, okay? But I wanted to let you know it is in the textbook, and there are some Algebra 2 trig classes and maybe some pre-calc classes that will have you use those rules. Here's what we're going to do. We're going to proceed with normal, and we're going to see a possibility of a couple things. If we ever get a domain error in our calculator, that's when we would say that there's no triangle. Got it? So you don't have to remember this, that, or the other thing. You just set up law of sines, and if you get a domain error, there's no triangle. So, and we'll talk, if it's an obtuse angle and we get an answer, we know that we can proceed. But if it's an acute angle, we kind of have some work to do. Remember that the inverse sine that's in your calculator is only trained to give that first quadrant angle, but sine theta is positive in both quadrant 1 and in quadrant 2. That means that we need to check if the supplement of theta, which represents our quadrant 2 angle, can be used to form a triangle with, okay? If you found the inverse sine in your calculator, right, if we wanted to find the inverse sine of 1/2, it only gives us 30 degrees. However, isn't it possible that it's also 150 degrees? Notice the sine of 30 is 1/2, and the sine of 150 is also 1/2. 150 degrees is possible for an angle of a triangle. So that's what we have to be careful about in this ambiguous case. But what we check, if we have to check if the found quadrant 2 angle plus the given angle is less than 180 degrees. That's essentially what we're going to see. And if it's so, a second triangle can be formed. So let's work on one of these. So this wants us to solve triangle ABC, and notice this is an a side-side angle case. We have an angle and a side opposite that angle, and then just this random side. So if we set this up this way, 63 over the sine of 127 degrees equals 42 over the sine of angle B, we can cross multiply, and based on the cross multiplication we've done in previous lessons, we can see that the sine of angle B will be 42 times the sine of 127 over 63. So to find the measure of angle B, we can take the inverse sine of 42 times sine 127 over 63, and we get 32.2 degrees. So the measure of angle B is about 32.2 degrees. Okay? Now, I'll just do the test with you. So what we want to see is what quadrant 2 angle is possible. So the quadrant 2 angle would be, we'll think about the 180, the 30 degrees one. If we had a 30 degree angle in quadrant 2, we would take 180 minus the reference angle to find the quadrant 2 angle. So that's what we're going to do here. Let's find the quadrant 2 angle by taking 180 minus 32.2 degrees. And when I do that, I end up getting 147.8 degrees. So that's our quadrant 2 angle. Now, let's add that to the given angle that we had, which was 127 degrees. If we added those together, notice that those two angles are too big to form a triangle with. The good news here is that means that there's only one triangle. And that's the gist of how we would test these different pieces. So we know that 147.8 degrees is not a possibility because a triangle cannot be formed with those angles. So we proceed just as we did in the previous lessons with this measure of angle B. We can find the measure of angle C by subtracting both 127 and 32.2 from 180. That gives us about 20.8 degrees. And then to find side C, I'll take the given 63 over the sine of 127 equals C over the sine of 20.8 degrees. I find that to get the length of side C, I'd have 63 times the sine of 20.8 degrees over the sine of 127 degrees. And if I put that in the calculator, again, here we're not doing inverse sine because we're just finding the side length. We end up getting about 28.0 as the side length. So the only thing that we're doing is just making sure that the reference angle that the calculator gives us when we do the inverse sine doesn't have a quadrant 2 counterpart that's able to create a triangle with. Let me be honest with you though. In example 2, we technically didn't have to do that. See how the measure of angle A is obtuse? And notice if your given angle is obtuse, as long as you get an answer in your calculator, it would just have one triangle. We'll talk about that together in a bit. All right, so let's try then example 3. Let's solve triangle ABC with these measurements. And I see that I have both a side B and an angle B. So I can set up that ratio, 4.7 over the sine of 52 degrees. That's going to equal 6.5 over the sine of A. So once I cross multiply and then isolate the sine of A, I end up with 6.5 times the sine of 52 degrees over 4.7. And so to find the measure of angle A, I'll want to use the inverse sine. So I'll take the inverse sine of 6.5 times the sine of 52 divided by 4.7 equals, oh no, look, it says error domain. That is the domain error I was referring to. What that means is that you're trying to tell the calculator to do something it can't do. So what happens is that if we find that we get this domain error, that means we're proceeding with something that was never true, which means that this indicates there is no triangle possible. Those are my favorite because like you're done after the first step, okay? So that's it. There's no triangle possible. So if you get a domain error, that's when you know that there's no triangle possible. Okay, so now let's look at example 4. Let's solve this triangle with these different measurements. And I know side A and angle A, so I'll use 32 over the sine of 62. And now I'll take 34 over the sine of B. So I'll cross multiply and isolate the sine of B. I get 34 times the sine of 62 over 32 equals the sine of B. So now I can take the inverse sine of 34 times the sine of 62 over 32, and that gives me about 69.7 degrees. So the measure of angle B is about 69.7 degrees. The thing is that we also want to double check because these angles are both acute, we want to double check to see if it's possible that instead we wanted an obtuse angle here instead. So let's see if the quadrant 2 counterpart would work. Remember, to get the quadrant 2 angle, we're going to take 180 minus the reference angle, and that gives us 110.3 degrees as our potential obtuse quadrant 2 angle. Okay, so now let's add that to the given angle of 62 degrees. Do you see that this obtuse quadrant 2 angle along with the original angle is less than 180 degrees? That means that both 69.7 and 110.3 are possibilities for that angle. So again, because this quadrant 2 angle that we found by subtracting the calculator angle from 180, because the quadrant 2 angle plus the given angle were less than 180, that also means that there's another possibility for angle B. Angle B could also be that 110.3 degrees. So how do we differentiate between the two of those angles? Well, let's call this first one the measure of angle B1, and we'll call the second one the measure of angle B2. And now everything that deals with B1, we'll put a subscript of 1, and everything that deals with B2, we have a subscript of 2. Okay? So let's just proceed with B1. We know angle A is 62 and B1 is 69.7. So what that means is that the measure of angle C1 would be 180 minus 62 minus 69.7. So that would give me about 48.3 degrees for C1. Now I'm going to take the ratio that I had, 32 over the sine of 62, and I'm going to use this angle C. So the sine of 48.3 degrees will be underneath that C. 1. Oops, sorry. So C sub 1. So again, when I cross multiply and solve, I find that C1 is going to be 32 times the sine of 48.3 degrees over 32, just kidding, over the sine of 62. With all the stuff you did with the law of sines the other day, hopefully you've got that down. And we can put that in our calculator, again, not using inverse sine, but I should end up with 27.1 for my C1. So one possible triangle has the original 3, along with an angle B that measures 69.7 degrees, an angle C that measures 48.3 degrees, and a side C that measures 27.1 degrees. But there's also a possibility that angle B could measure 110.3 degrees, which means that we would have a different measure for angle C2. With an angle of 62 degrees and an angle of 110.3 degrees, the only thing left in that triangle would be 7.7 degrees, and that would be the measure of my angle C2. So then I would take, again, the known ratio from the very beginning with A and the angle A, 32 over the sine of 62. Now we're going to set that equal to C sub 2 over the sine of 7.7 degrees. So cross multiplying, I find that C sub 2 would be 32 times the sine of 7.7 over the sine of 62 degrees. And so that means that side C2 would be 4.9 units. So a second possibility for this triangle is to have these 3 original measurements and an angle B that measures 110.3 degrees, an angle C that measures 7.7 degrees, and a side C2 that measures 4.9 units. So that's really the gist. Those are the different types of things you could have. One triangle, no triangle, Ms. Lang's favorite, and then 2 triangles. All right? So here's kind of a way that you can tell how many triangles that you're going to have so that you don't always have to test, okay? Anytime you have 2 angles and one side, that means that it's just one triangle that can be formed. So that's super nice. Those were most of the ones that you had the first day. 2 angles and a side, and you're using the law of sines, it's always one triangle, all right? When you have 2 sides and 1 angle, that's where you have to be careful, okay? So the nice thing is that if you get a domain error, then there's no triangle, okay? If you are able to get an answer, so no domain error, if you get an answer and the given angle is obtuse, you know, again, that there is just one triangle, because there's only one obtuse angle that's possible in a triangle. So there's no way that 2 obtuse angles could exist, because that's what the quadrant 2 angle is, an obtuse angle. But let's say that you get an answer, so no domain error, that you're actually able to get an answer and the given angle is acute. That is when you have to test the quadrant 2 angle, okay? And again, the quadrant 2 angle is what you take when you get 180 minus that reference angle that the calculator gave you, okay? So take a minute, and I'd like you to try this first U try that you have, okay? Take a minute and do this U try. So go ahead and pause. Okay, so I have the first portion of this. I set up my proportion, and I'm able to get an answer. I find that the measure of angle B is 34.4 degrees. So then, because I'm able to get an answer, and this of course was an SSA case, because I was able to get an answer, I look at my given angle. I see that my given angle is obtuse. So since my given angle is obtuse, I know that there's only one triangle. So then I can proceed and find the other pieces. When we do that, we find that the measure of angle C is 23.6 degrees when we use the triangle sum formula. We can then, again, always use the exact values that you're given in the problem. We then can set up the next ratio and isolate C, and if we were to multiply that out and put in the calculator, we end up that C is about 8.5. So that's a way to do letter A, okay? So now let's take a few minutes and try letter B. Okay, so what I did is I set up the ratio, and I found, or the proportion I should say, with the 2 ratios, and I found that the measure of angle B is 51.6 degrees. Notice that the original angle was acute, and we got an answer, so that means we have to test the quadrant 2 angle. So a 51.6 degree angle in quadrant 2 would mean we'd have 128.4. Again, 180 minus 51.6. So now I see, okay, can I form a triangle with that second quadrant angle of 128.4 and 36? Well, when you add, because it's less than 180 degrees, that tells us that, yes, indeed, there are 2 triangles that are involved. So that B1 is going to be the 51.6 degrees, and that means then that the measure of angle B2 is that quadrant 2 angle, that 128.4 degrees. Now we're going to continue twice. So I'm going to pause and do the rest of that for myself real quick. Give me a sec. Okay, so here's the rest of what I have. So what you do is you just totally focus on the first angle and continue. So if the measure of angle B sub 1 is 51.6 degrees, that means that the measure of angle C sub 1 is 92.4 degrees, and then the length of side C would be 15.3. Then we focus on using 128.4 degrees. If that's the case, then the measure of angle C sub 2 is 15.6 degrees, and then the measure of side C2 is about 4.1 units, okay? So make sure that you're checking your answers to make sure that if the answer key has 2 triangles, you should be getting 2 triangles. And if you only have one answer, go back, find your quadrant 2 angle, and observe that there is a third angle possible with the quadrant 2 angle and that given angle, okay? The last one that we have is you try letter C. So you can take a second and do that one. Okay, why this was one of our favorites. We set it up, and the issue is that when we try to substitute that in our calculator and find the inverse sign, we get a domain error. So that means that there is no triangle. Yay. So that's the gist. If this wasn't good enough for you, I'm sorry. You can Google the law of signs, the ambiguous case. Maybe you can find some other videos on that, okay? So that's that. Do your best. And again, check your answers as you're going, and, you know, check for those triangles that might have two triangles in them, okay? All right, have a good one.